Hello, this is Mr. DeLapp. Again, we're doing now the second of the level 2 torque calculation problems, number 5. Again, these level 2 problems address calculating torque when the force applied is at an angle that is not perpendicular to the lever. So number 5 asks us to calculate the torque on the lever. So to calculate torque, this is the modified version of the equation, torque, or tau, is equal to the force that's applied times the position vector, or the distance between the force and the pivot point or the fulcrum, times the sine of theta, and that's the angle. Now, in the level 1 problems, the angle we've been dealing with when it was perpendicular were 90 degrees. And so if you get the sine of 90 degrees, you end up getting 1. And so the amount of torque we end up getting from it is unchanged because you're multiplying times the sine of 90 degrees, which is 1. But that's not the case this time. This time we have 30 degrees. So our theta, we could say in this case, is equal to 30 degrees. We got a force that's applied, which is in newtons. That's how we identify it. So we have a force being 40 newtons, and our position vector is equal to 1.5 meters. Now, when I plug this in and do a substitution, what we end up getting is 40 newtons times 1.5 meters times the sine of 30 degrees. So I can calculate this by doing 40 times 1.5. That's going to be 60 Newton meters. And if this force was all perpendicular, then that would be it, and we would just have to figure out the direction of the problem. But because it's at an angle, we have to calculate the sine of 30 degrees. So in your calculator, you would hit 30 and then hit sine. And what you should get if you do that correctly is a number like 0.5. And what that means is that if I took this angled vector and I dropped right from the end of it, right or perpendicular to the lever, and made a 90-degree angle, I'll use this one here. It is only this component that is actually contributing to the torque. This is what the perpendicular force is. So if you wanted to calculate it, you could actually get that just by doing the force times the sine of theta. And since sine of theta is 0.5, it would mean that only 20 of these 40 newtons are contributing to torque. So as a result, I get 30 Newton meters. Now I'm just about done. The last thing I need to do, which we did not do in the previous problem, but we had to do in the level 1 problems, is determine the direction or the sign of the torque value. And so since this force is pushing this way, which is going to cause the lever to turn around in the counterclockwise direction, we would then determine that the torque would have to be positive. So our answer in this case is 30 Newton meters. Thank you very much for your time. And we have one more problem, maybe 2 to go, but that's it.